I know I already talked about it, but subtraction is going to work the same way as our addition. I want to give you a chance to work this one before I jump right in it, since it has some variables and you haven't worked one with a variable. So see if you can subtract these. Your final answer will have an x in it. We're not getting solving for x. Your final answer is just going to be something like 3x over 7, something like that. So go ahead and hit pause and give this one a shot. Let's see how you did. The least common denominator for this problem is 12. That's the smallest multiple that is there for both 3 and 4. You also could find just any time a common denominator would be multiplying the two of them together. 3 times 4 happens to give me the least common denominator this time. So for this first fraction, I need to turn 3 into 12. So I multiply by 4. For the second fraction, again turning it into 12, I would multiply by 3. That's going to give me 8x over 12 minus 3x over 12. Subtracting the numerators, I would get 5x, and the denominator stays the same to give me 12. So let's take a look at a subtraction problem here. This is listed as a 4th grade problem by Pearson. So they would say this would be what would happen at a problem that could happen at the end of 4th grade. So we've got jelly beans here, and Anna's going to take 1/4 of them, Ben's going to take a 1/6, and Carlos is going to take an 1/8. We don't know how much of the bag is left. This is a multi-step problem, so it'll probably be something that you would work toward all year. You can think about this being an end of course test or something like that as we're going through. It's not going to be something you would do the very first day of 4th grade. So lots of different ways that you could possibly set this up, but you will have to get 2 things. You'll have to get a common denominator, and you also will have to subtract at some point. Doesn't really matter if you're subtracting at the beginning or the end. I'm going to set up that I would subtract right away, but you could subtract at the end. So the bag that we have is going to represent 1. That's the entire bag. Anna's going to take some, and when we take things, it is subtraction, then Ben, then Carlos. So that would be our problem. The other alternative is to add together the fractions, so the 1/4 plus 1/6 plus 1/8, get that answer, and then subtract that answer from 1. So you would, either way you work it, you're going to get the same answer. The answer, I'll tell you, is 11/24, because I know this is one that people want to know if they got it right away. But go ahead and hit pause, see if you can get 11/24, and then we'll come back and go over it and see. Hopefully, you'll see exactly what I did, maybe match it up to your work to get the 11/24. If not, then you maybe will see where your mistake went wrong. So hopefully you got 11/24. If not, that's okay. We're going to see what might have happened, where you went a little off course. So between my denominators of 4, 6, and 8, the least common denominator would be 24. If I were to list out the multiples of 4, the multiples of 6, and the multiples of 8, like we did in chapter 4, when I would list those out, 24 would be that least common multiple. I'm going to use it as a denominator now, so I'm going to call it the least common denominator. So I need each of these to turn into 24. They're going to have to be multiplied by a different number in order to get them to turn in to 24. But remember, the numerator and denominator would be the same. So that would give me 6/24, and then 4/24, and then 3/24. And 1 is the same thing as 24/24. 1 is the same thing as whatever I need my denominator to be. It could be 70/70, or 3/3, or in this case, 24/24. And then I'm going to subtract 24 minus 6 minus 4 minus 3 gives me 11. The other alternate way you could work it is get that common denominator. If you add them together, you would get 13/24, and 1 minus 13/24 is 11/24. All right, We've got one other problem here. This one's going to be dealing with our mixed numbers. Again, multiple ways you could work this and all get down to the same answer. So we've got a big long board that's 38 1/4 inches. And we need to cut a board that's 15 3/4 inches from it. So we're cutting something away. So again, it's subtraction. And then we're told that the saw also takes 3/8 of an inch. You know, all that sawdust that falls down whenever you're cutting something. We want to know how much of the board is left. So we'd have 38 1/4 minus these guys. Again, you could possibly add the 15 3/4 and the 3/8 together and then subtract that. So multiple little paths we could go down here and get the same answer. Now what we don't want to have happen is just to subtract those whole numbers, the 38 and the 15, and then subtract the fractions. We can't really do that. And that's pretty easy to see in this problem because you cannot have 1/4 minus 3/4. That would give us negative numbers. So before, I can't just keep these as mixed numbers. Instead, I need to change them to the improper fractions. So I'm going to do that multiplying and then adding. So 38 times 4 is going to give me 152. Then over here, I've got to multiply the 15 times 4 is going to give me 60 plus 3. And then 3/8 is already written in fraction form. So really my problem is 153/4 minus 63/4 minus 3/8. So what I've done is I've taken these mixed numbers and turned them into improper fractions. Now I'm going to get a common denominator. You could have gotten a common denominator, I guess, to start with, but I went on and changed mine. First, a lot of different paths, like I said, that you could have gone down. We could have started by getting a common denominator and then switched to our improper fractions. So either order would have been fine. My least common denominator between 4 and 8 is going to be 8. So one's already good to go. These other ones, I've got to multiply by 2. So 153 times 2 is going to give me 306/8. And then 63 times 2 is going to give me 126/8. I can subtract the numerators to give me 177/8. I know the directions didn't say this, but usually if we give you numbers as mixed numbers, the answers are going to be wanted as mixed numbers. You'll see in my math lab how they want them because it'll be directions right after the box you type your answer in blue. It'll tell you kind of what form they want them in. So just as some practice, I'm going to change this to a mixed number. So I want to split this 177 up into two numbers. So it might be 170 plus 7, for instance, or 175 plus 2. So I need to figure out a multiple of 8 that is as close as I can get to 177. I don't know my multiples of 8 up there, so I'm going to do some trial and error on my calculator. I will tell you one way to do it is you can divide this, 177 divided by 8. And when I type that in my calculator, I got 22.125. So that told me that whole number was 22. It was 22 and a fraction. I know we haven't got to decimals yet, but I'm going to go ahead and kind of give a little sneak peek of it. That's the whole number plus that fraction. So 8 times 22 should get me what I need to split up my numerator. That's going to give me 176. So that's always is a way to figure out what that numerator addition should be. So now I've split it into a whole number and a fraction. So that's 22 1/8. Feel free to rewind that. I know that's a lot to take in with that mixed number there. That's always something that's Sometimes people need me to explain again if we're face to face. So feel free to rewind it, watch it, and shoot me an email if you have any questions at all.